My name is Ton Allesma. I'm phytopathologist at Bayer Crop Science in the Netherlands. Resistance is the ability to withstand damage due to a threat. In plants, resistance is used to describe the ability of the plant or the variety to restrict the damage caused by a pathogen. Restriction of damage by a pathogen can be due to restriction of growth of the pathogen, restriction of the symptoms of the disease, or restriction of the financial damage, or a combination of those. The time to discover a new resistance trait depends on various factors. First, how easy it is to develop a resistance screen test to discriminate between resistant or susceptible plants. Then how easy it is to grow the pathogen and how widespread the resistance is in the plant. It could be that the resistance is widespread and available in tomato cultivars, or it could also be that the resistance is present only in one specific accession within a very wild species. I have to say that the identification of the resistance is only the first step in a long process. When the resistance is discovered, then the next step will be to integrate it into a commercial cultivar. And then it depends on where the resistance is located. If it's in a wild species, it requires multiple backcrossing cycles to get the resistance into a commercial product. And of course, modern tomato varieties are loaded with all kinds of quality traits, and our customers does not want to be back with lower quality traits. So the resistance has to be integrated into a product with all the existing quality traits, and that's also a very difficult step. At Bayer, we use multiple technical solutions and technical tools to integrate this trait as fast as possible. ToBRFV is not specifically complex. We have similar traits with the same complexity. The major difference with ToBRFV is that it is a highly aggressive pathogen that has spread rapidly across the world and is causing large damage in one of the major crops that is grown worldwide. ToBRFV was first discovered in 2014 and has spread within 5 years all across the globe. And that gives the companies very little time to react and respond and to find resistance. Durability of a resistant gene is very unpredictable. The resistance is an interaction between the plant resistant gene and a factor in the life cycle of the pathogen. And the main question here is how easy it is for the pathogen to circumvent this step in its life cycle. If that's a small step, then it will be very easy for the pathogen to circumvent this step and find another way to complete its life cycle, and then the resistance will hold very short. However, if it's a really crucial step in the pathogen life cycle, it will be very hard to overcome, and resistance can be very durable. For example, the TMT22 gene in tomato, which holds to tomato mosaic virus race 2, has been durable for over decades. The difference between intermediate resistance and high resistance is the ability of the plant to restrict the pathogen in its growth. Resistance is due to resistance genes that have a specific interaction with the pathogen. And in some cases, only one single gene is sufficient to cause sufficient protection to the pathogen. In other cases, however, we need multiple genes to give the same level of protection, or a combination of resistance genes with other measures. In cases that we need multiple resistance genes to give protection, it could be that the varieties differ in the number of resistance genes that they have introgressed, and that causes differences in the ability to restrict the pathogen growth. In those cases, to discriminate between these two levels, we talk about intermediate resistance and high resistance. A definition of IR and HR is described by the International Seed Federation. This definition is valid for all crops and all pathogens, and therefore it is hard to set a strict line between what is IR, what is HR. And this implies that there is, for a given crop pathogen combination, room for difference in interpretation on the resistance level. Resistance claims are independently verified by the examination offices like the Naktuinbouw in the Netherlands. However, this is only in the scope of the DOS examination. The DOS examination, which stands for difference, uniform and stable, is a regulatory test that needs to be done to secure that new varieties are really new and not a copy of an already existing variety. The DOS claims have no conclusion about commercial value. Commercial claims are the responsibility of the individual companies, and therefore Bayer has an internal process in place to validate its resistances before a new product is launched to the market. Regarding ToBRFV resistance, we're making good progress. We have identified resistance genes and are introducing these in our pipeline. For the high-tech glass market, we have recently launched a first intermediate resistant variety named Strabini. We have launched 2 beef tomato products in the US and Canada recently with a higher level of resistance to ToBRFV. We expect that by October of 2023, we will have multiple new products with resistance to ToBRFV that are being trialed. Recently, we made as Bayer a big investment in new quarantine facilities to test ToBRFV resistance. With these new facilities, we expect that we can speed up the process even more and think that we can launch extra products in the future.